Hello students, this is a topic test video for tests on QA available on Bodhee Prep. The idea of these tests is you cover the basic concepts of a topic to be sure that they're actually completed. You take these tests. With every test, there is a video, gives you the solutions and a brief analysis of what would have been a good attempt. More than 200 such topic tests are available on the Bodhee Prep Android app. The link for the app is in the description, so make sure you download the app and make the most of these tests. This video is on Maxima Minima. This test number 2 is being discussed. Moderate level of difficulty, about 6 questions in 22 minutes would give you a 95 plus percentile. 6 questions means 6 questions being net correct, and that is the number of questions for which we are trying to measure the time. If we look at the questions, the first one says x plus y plus z is 36, where x, y, and z are positive real numbers. Find the maximum value of x square y z cube. Since two terms of x are required, I write x as x by 2 plus x by 2. Y comes as it is. Power of z is 3, so we write as write z as z by 3 plus z by 3 plus z by 3. Now, the product of these terms will be maximum for a given sum when all of the terms are equal. We have 1, 2, 3, 4, 5, 6 terms. So, if each of the term is equal, each of the term will be equal to x by 2 will be equal to 36 by 6, which is 6. Y will be equal to 6. From here I can write x is equal to 6 into 2. Z by 3 will also be equal to 6. So Z will be equal to 6 into 3. And therefore, if I have to find out the maximum value of x square, y, z cube, we substitute these values. X is 6 into 2 square, y is 6, z is 6 into 3 cube. 6 is 2 into 3. So 2 square into 3 square into 2 into 3 into 2 into 3 square cube. 2 raised to power 4 into 3 square into 2 into 3 into 2 cube into 3, 6. 4, 5, 6, 7, 8, 2, 3, 9. And therefore the maximum product becomes 2 raised to power 8 into 3 raised to power 9. Moderate question, would have done questions like this earlier, about 2 minutes to solve. Y is equal to 66 by x plus x. What is the maximum possible value, integer value of y such that x is less than 0? Now, we know that AM is greater than equal to GM. Therefore, 66 upon x plus x by 2 will be greater than equal to under root of 66 upon x into x. Therefore, 66 upon x plus x should be greater than equal to 2 into root 66. If we say y is equal to this value and x is negative, if x is negative, this entire term becomes negative. And therefore, instead of 2, what we do is, if you want to take the positive value x, will multiply this by y with a negative sign. Therefore, we can say y is less than equal to minus 2 root 66. X 66 upon x plus x will be greater than equal to 2 root 66, and x is positive. If it is negative, we multiply the entire thing by minus 1. And therefore, the maximum value of y has to be minus 2 into root 66. If y is an integer, root 66 has to be will be something about 8 point something. And therefore, the maximum value of y will be minus 2 into 8 point something. Therefore, y has to be less than minus 16 point, suppose 66, I'm taking the root as 8.2. So y has to be less than minus 16.4. The next integral value less than minus 16.4 is minus 17. And therefore, the maximum value integral value that y can take such that x is negative will be minus 17. These kind of questions are common in CAT nowadays, at least in the last 2-3 years, and therefore about a minute and a half to 2 to solve, moderate level of difficulty. ABCD are distinct positive real numbers, then A plus C into B plus D into AC plus BD upon ABCD is always A plus C into B plus D. B plus D. This I am writing as AC plus BD upon ABCD. Here we can write AB plus BC plus AD plus CD multiplying the first two terms is equal to AC upon ABCD will be 1 upon BD plus BD upon ABCD will be 1 upon AC. Multiplying them further, AB into 1 by BD will be, or we can write each of them, so AB plus BC by BD, AD by BD, CD by BD. Multiplying each term 1 by 1 is what I am doing. BC by AC, one term from here, multiply by this, then these two, AB 1 by AC, BC 1 by AC, AD 1 by AC, CD 1 by AC. B and B cancel, A by D. B and B cancel, C by D. D and D cancel, A by B. D and D cancel, C by B. A and A cancel, B by C. This becomes a pair. B by C. C and C cancel, B by A. A by B, B by A also becomes a pair. A and A cancel, D by C. So this comes here. C and C cancel, D by A. So now if you look at the 8 terms, we have 4 pairs. A by D plus D by A. C by D plus D by C. A by B plus B by A plus C by B plus B by C. Now we know that if there are 2 terms, or x plus 1 by x is always greater than equal to 2. Each of these terms of the expression is a sum of 2 reciprocals, and therefore this will be greater than equal to 2, greater than equal to 2, greater than equal to 2, greater than equal to 2. Since they are distinct numbers, therefore definitely one of the value will be greater than 2. Cannot be the same for all of them, and therefore the sum will definitely be greater than 8. Hence option B becomes the answer. It will be equal to it when A, B, C, D are all the same, and therefore each of the values will be 2, 2, 2, 2. But since they are distinct values, the values have to be greater than 2, and therefore the overall sum will be greater than 8. Again, in terms of level of difficulty, there is a lot of arrangement that goes on, therefore I'm saying difficult. But once you are able to see that the kind of expression that you want in the end should not take about 2 to 2.5 minutes to solve. What is the minimum value of the expression x square plus x plus 1 upon x square minus x plus 1 for all real values of x? Now, this real values becomes my starting point. What I do is we keep the expression equal to, say, m. Right? And then rearrange it to get a new quadratic equation. M x square minus mx plus m. Therefore, x square into 1 minus m plus x into 1 plus m plus 1 minus m is equal to 0. So we have a quadratic equation in x, and we know that x has real values. If x is real, b has to be greater than or equal to 0. The moment we put the value for discriminant, we will get a quadratic in m, from where we'll get the range for m, which is the range for the expression. So if the discriminant is 0, we can say 1 plus m square b square minus 4 a c is greater than or equal to 0. 1 plus m square plus 2m, this becomes minus 4 into 1 plus m square minus 2m is greater than or equal to 0. 1 plus m square plus 2m minus 4 minus 4m square plus 8m is greater than or equal to 0. So minus 3m square plus 10m minus 3 is greater than or equal to 0. Multiplying by negative, we get 3m square minus 10m plus 3 is less than or equal to 0. This can be written as 3m square minus 9m minus m plus 3 is less than or equal to 0, which means 3m into m minus 3 minus 1 into m minus 3 is less than or equal to 0, or 3m minus 1 into m minus 3 is less than or equal to 0. So critical point become m minus 3 0, m is equal to 3, 3m minus 1 0, m is equal to 1 by 3. Positive, negative, positive. So m will lie between 1 by 3 and 3. What is the minimum value of the expression? Minimum value of the expression is 1 by 3. Option C becomes the answer. This is a standard procedure in a question like this. Will always work. The attempt time might go up to 2.5 odd minutes, but at least the answer is sure. And therefore, I'm saying moderate, about 2.5 minutes to solve. Another approach for this question could be working with the expression and from there trying to minimize. So if I look at this, I can say x square plus x plus 1 upon x square minus x plus 1. This can be written as x square minus x plus 1 plus 2x. Basically, add x and subtract x upon x square minus x plus 1. This gets divided, so 1 plus 2x upon x square minus x plus 1. Divide the numerator and denominator by x. 2 upon x, x square by x minus 1 plus 1 by x. So this is what we get. Now, if x plus 1 by x is greater than or equal to 2. So if we put 2 here, we'll get 1 plus 2 by 2 minus 1, which will be 3. As x plus 1 by x increases, this value will decrease and therefore the overall value will decrease, and therefore 3 becomes the maximum value. Similarly, for negative, we will say x plus 1 by x is less than or equal to minus 2. If we put minus 2 here, we will have 1 plus 2 minus 2 minus 1. So this will give us 1 minus 2 by 3, which will be 1 by 3. That becomes the minimum value for this expression. Either way, option C was the answer. This could have been the second approach for this question. In a locality, each family has at most two adults. No family has less than 3 children. So if there is a family, there will be maximum of 2 adults. So if the number of families is f, number of adults has to be less than or equal to 2f, at most 2 per family. Children will be greater than or equal to 3f, because it has no family is less than 3 children, 3 or more. Considering all the families in the locality, there are more adults than girls. Adults is greater than number of girls. More girls than boys. More boys and girls plus boys will be the number of children. Find the minimum number of families in the locality. Now, number of adults is 2f. 2f is greater than g, is greater than b, is greater than f. Whatever the value of f is, Number of adults will be 2f. We need at least two numbers in between. If I put f as 2, this will be 4. There is only one number in between. Therefore, the minimum value that I need for f is 3. If we put this as 3, the number of families will become 3 2s are 6. The number of children in this case will be 3 3s are 9, which can be divided as 5 and 4. So if we put number of families as 3, which becomes a minimum number, the number of adults comes out to be maximum, which is 6. Number of children minimum 3 into 3, 9 can be used. That 9 can be divided as 5 and 4. And therefore, this inequality will also prevail where adults is greater than number of girls, is greater than number of boys, is greater than number of families. So minimum number of families required is 3. Moderate level of difficulty. The numbers are small, therefore, even if we try with different values, should not take about minute and a half or 2 minutes to get the answer. If x is greater than equal to 0, the minimum value of x plus 7 into x plus 25 upon x plus 1. X plus 7 upon x plus 25 will be x square plus 32x plus 7 into 2. 140, 175 by x plus 1. On dividing, we'll get x square plus x square plus x. If we take out x plus 1 from here, this can be written as x square plus 32x. Since we're taking out 1 from here, 31 will remain plus 31. Taking 31 out of 175, we'll have 144. Basically, I'm trying to break down x plus 1 into x plus something. That something will be 31. So this becomes x plus 1 into x plus 31 plus 144 upon x plus 1, which further can be written as dividing this product by x plus 1, you're left with x plus 31 plus 144 upon x plus 1. X plus 31 can be written as 30 plus x plus 1 plus 144 upon x plus 1. Now, I look at this term here. We know that AM is greater than equal to GM. And therefore, x plus 1 plus 144 upon x plus 1 by 2 will be greater than equal to root of x plus 1 into 144 upon x plus 1. So this term x plus 1 plus 144 upon x plus 1 will be greater than equal to 2 into x plus 1 cancel, root of 144 is 12. So this term has to be greater than equal to 24, and therefore this entire sum has to be greater than equal to 30 plus 24, which is 54. Therefore, the minimum value of this sum will be 54. That becomes my answer. Could also have equated it to 2 and from there work with the discriminant. But I thought this is a better approach. Overall, it's a difficult question. About 2.5 minutes to solve. Let gx is equal to minimum of 11 minus x plus 4, the largest possible value of gx is. If we draw these lines, 11 minus x, y is equal to 11 minus x. When x is 0, y will be 11. When y is 0, x will be 11. And therefore, we get a line something like this, 11, 11. X plus 4, y is equal to x plus 4. When x is 0, y is 4. When y is 0, x is minus 4. So x is minus 4. Something like this. Now, if you look at gx is the minimum of these two values. So gx will trace this line till this point and then start to go down. Because of these two, the value at the lower end will be the minimum value. And therefore, the highest value of gx will be this point, where both the terms or both the lines are equal. And therefore, the maximum value of gx will happen when 11 minus x is equal to x plus 4, which means 2x is equal to 15 or x is equal to 7.5. not 15, sorry, 11. 11 minus 4. 2x, 11 minus 4 is 7, 3.5. And the maximum value will be 11 minus 3.5, which is 7.5 or 15 by 2. Option C. At x is equal to 3.5, the value of gx will be 15 by, put the value of x here or here, and that will give us the answer. This is an easy concept, and the numbers are also small, so not more than a minute and a half to solve. If 12p plus 3r plus 4q is 16 and pq are positive real numbers, maximum possible value of p cube r cube q square. P cube r cube q square. The value of the power of p is 3. So we write it as 4p plus 4p plus 4p. R is also 3 times, so r plus r plus r, 3r. Q is 2 times 4q, so 2q plus 2q, split into 2 parts. This is 16. For a product to be maximum and a given sum, all the terms have to be equal. So the maximum product of 4p cube into r cube into 2q square maximum will happen when all the terms are equal. Also, this is nothing but 4 cube into 2 square into p cube r cube q square. If this is maximum, by default this will also be maximum because 4 cube and 2 square are constants. Now here we have 1, 2, 3, 4, 5, 6, 7, 8 terms. 16. Therefore we can say 4p should be equal to 2, 16 by 8. R should be equal to 2 and 2q should be equal to 2 to get the maximum product from here. And therefore this will be 4p. 2 cube into 2 cube into 2 square. So 4 cube, which is 2 raised to power 6 into 2 raised to power 2 into p cube into r cube into q square becomes 2 raised to power 8. 2 raised to power 8, 2 raised to power 8 cancel. So p cube into r cube into q square, maximum value is nothing but 1. Basically from here we are getting p as 1 by 2, r is 2, q is 1. Put the value of r is 2, q. Put the value of p 1 by 2, r 2, q 1. The maximum product will come out to option A. That becomes my answer. Let x, y, z be positive real numbers such that x into y into z is 1. What would be the maximum value of this one? Now, am is greater than equal to gm, or we can say gm is less than equal to am, and therefore x minus 1 plus 1 by y into y minus 1 plus 1 by z into z minus 1 plus 1 by x. Cube root of this will be less than equal to am. X minus 1 plus 1 by y plus y minus 1 plus 1 by z plus z minus 1 plus 1 by x upon 3. Solving the right hand side, get the value x plus y plus z plus 1 by x. Now 1 by x from here can be written as yz. 1 by y can be written as xz divided by y. And 1 by z, if you bring z down, 1 by z will be equal to xy. So this 1 by y, 1 by z, 1 by x can be replaced with yz, xz and xy. Then I have 1, 1, 1 minus 3 upon 3. Now what I do is I add xyz here. Value of xyz is 1, so subtract 1. Plus 1 minus 1. xyz plus xy plus yz plus zx plus xy plus 1 plus xyz. This expression is nothing but x plus 1 into y plus 1 into z plus 1. minus 5 by 3. The minimum value that this will take, since x into y into z is 1, the minimum value will happen when x, y, z, all three are 1, and therefore x plus 1, y plus 1 into z plus 1 will be 2 into 2 into 2, that is 8. So if you put the value here, this becomes 8 minus 5 by 3, which is 1. Therefore, I can say cube root of, suppose if this is the value a, I can say cube root of a is less than equal to 1, which means a will be less than equal to 1. So the maximum value that a will take will be 1 becomes my answer. I think overall difficult question would take time to rearrange, and then also to we'll have to use maximum minimization in two separate cases. Therefore, difficult questions. A is 3, 23, 43, and so on till 603. S is a subset of A. If the sum of no two elements of S is more than 606, what can be the maximum possible number of elements in S? So, number of elements in S is 3. 3 plus 20. 3 plus 20 into 1, and so on till 3 plus 20 into 30. There are 31 elements. The element in the center will be 3 plus 20 into 15. The 16th element. Now, if we look at these terms, 303 added to anything that is greater than 303 will definitely cross 606. 303 added to anything that is less than 303 will be less than 606. And therefore, what we can do is we can take all the first terms till 303. The sum of any two of these will be less than half, will be less than double of the highest term. If we are taking anything that is beyond 303, any two terms will always add up to more than double of 303. So what we can do is we can choose terms from 3, 23, 43 up to 303, which will be a total of 16 terms out of 31. They can be put in S. Basically, half of 606 and less than that, adding two terms will never reach 606, and 16 therefore becomes my answer. I think this is not a difficult question. Overall 1.5 minutes should be good enough to figure out what is happening. So if you look at the overall test, because some of the specific questions, I am saying difficult overall test, because some questions were hard to tackle. 6 questions in about 22 minutes, which will be these questions. For me, they would be 1, 2, 5, 7, 8, 10. Definitely doing this. Have done similar questions earlier. This again, because a similar question was asked in CAT, therefore have attempted such kind of a question earlier, therefore will be able to do it again. This may or may not happen. Sometimes it is easy to get confused with the variables, not counting this as a sure shot question. This again, unless you know what you're doing, might be a little difficult to manage. This one was easy, simple numbers will give you the answer. Again, unless you're sure what you're doing, this might be a difficult question. This is a standard process. Nothing. All we have to do is make sure the slopes are different, equate them, and get the answer. So definitely attempting this question. This question again is of similar format that we've done earlier, and therefore a sure shot question. I thought this was a difficult question, not attempting this in the exam. This again was a simple question where we're looking at half the set. Therefore, would have attempted it. So my 6 attempts would be from 1 to 5, 7, 8, and 10.